Hey, it's almost end of May 2023, which means we are about 8 months away from the next February 29th, which is a date when usually we have a bunch of software bugs popping up. So I thought, how about we discuss about it so that you have enough time to fix those potential issues before we get there. Welcome back to Think Design Work Smart. I'm Alex Bolboaca, and I'm coming at you from the Mozaic Works studios. And today, what I have for you is a discussion, an explainer about DateTime issues. The first explainer that we did the last time was got some very positive reactions, and so we thought, oh, let's do some more. So today, DateTime issues. What are some DateTime issues that we think about? Well, remember a few of them. Time zones. Time changes depending on where you are on Earth. And of course, there's the UTC time, which is standard and it's only one. But if you don't use it or don't know how to use it, I've seen a lot of bugs due to that. Daylight saving time. The hour changes on specific days. It goes 1 hour ahead or 1 hour back, which means that once again, if you're storing dates in the local time, if you're storing daytime in the local time, you might have a few surprises. Leap years, very common issue with leap year bugs. And we'll discuss more about those. International dateline. Not many people know, but if you travel long enough around the Earth, surprise, you end up in crossing the international dateline, which changes your date. It goes 1 day forward or 1 day back. And something that will just touch a little bit, relativistic effects. We won't talk too much about those because those are quite rare. So what are some things that we need to pay attention to? Some wrong assumptions that are leading to bugs. First assumption, which is intuitive, right, is that time always moves forward. Second, February has 28 days. Third, hours go from 000 to 23:59:59. Turns out none of these are true all the time, right? Well, I'm being facetious a little bit. Okay, time moves forward. The problem is the things that we are storing. So when I'm talking about time in this video, what I'm really talking about is about the values that we deal with in code, the datetime values. If you think about time in the abstract, based on everything we know, it moves forward. But the date and time values don't necessarily move, don't necessarily grow all the time. So time moves forward, except unless you are switching time zones or crossing the international daylight or during the daylight saving time change. So what is important here is not to assume if you are storing or if you are dealing with local time values, never assume that they will be always growing. And this is a hidden assumption that's often creating issues in your code. Imagine you have some algorithms that sort time series or that depend on the order of events, let's say in a database, based on a time series. If you miss this fact, if you're storing in local time and you miss the fact that there's a 1 hour difference from time to time, or a 1 day difference if you are moving around the Earth, you might be in some trouble. Now, normally, if you are just writing software for let's say, static kind of things, like the server is in one place or in multiple places, but let's just assume you have a server, let's say somewhere in Europe or somewhere in US. You connect to it. It has a specific time. You have your local time. You can make these things work. A big challenge is, however, if that server or your local time is changing depending on where you are. So, for example, if you're writing ship software for ships that are traversing in the international date line, when will you find out that you have a bug? Well, when the ship is in the middle of the ocean, which might be a bit of a problem. And that's the general challenge with all these things. The bugs, you will find the bugs at some of the worst moments, like after daylight saving time, on January 1st, or on February 29, when the daylight saving time happens in a specific location, and so on. So pay attention, right? These are assumptions that you need to avoid because these are bugs that you'll find in moments that are not the best, right? Let's talk a bit about the international dateline, because this is something that is not so clear for many people. First of all, it's not really a straight line. And the reason is because you want to have these, let's say you are living on an island somewhere and near you there's, or close to you, there's another island. If on a very close proximity, on an island is Sunday and on another island is Saturday, this raises a few problems. So because of this, the international dateline looks a bit weird. And it's quite funny. But the big thing is, yeah, it's Sunday on one side, it's Saturday on the other side. So if you are crossing this with a ship and synchronizing to the local time, then you are switching the date. If you are storing time series in the local time, you might have a problem. If your program, let's say you are having some kind of navigational software and it assumes that time will always move in one direction, well, you have suddenly went back to the past, so not that great. Now, quick intermission here. I asked ChatGPT, actually Bing Chat, to write 3 witty statements about the international dateline, and this is what it came up with. The international dateline is the ultimate way to avoid commitment. You can always say you have a date on the other side of the line. I'm not sure how witty it is. The international dateline is the best place to celebrate your birthday. You can have 2 parties in 2 days without getting older. Oh, if only that would be true. The international dateline is the worst enemy of procrastinators. They can never say they will do it tomorrow because tomorrow is already here. So I leave up to you to judge whether these are good witty statements or not. They are, for me, they are slightly funny anyway. Okay, let's move to the next one. February has 28 days except in a leap year, when it has 29 days. Hours go from 000 to 23:59:59, except when we have a leap second, and then we have also the time 23:59:60. Now, leap seconds are quite controversial, and different providers like Google, Microsoft, Amazon, they treat them differently. Some providers just spread that second over multiple well, over a longer period of time. So basically, they slow down the clock a little bit to um, to avoid having time 23:59:60. It doesn't mean that this will happen for everything. But you need to know that this thing exists because, again, presumably, you might have some issues with it in your software. Okay, so let's talk about some realities of date and time. Well, time and date depends on where you are and how fast you are going, and also on the value of gravity. I said we won't talk a lot about relativistic effects, but they are worth mentioning a little bit. How fast you are going influences the speed of time and the value of gravity. So depending on the differences in gravity between where two clocks are placed, you'll have different speeds of time. These are the relativistic effects. They don't matter a lot if you are on Earth, right? Because we have the same gravity and our speeds are nowhere close to the speed of light. But they start mattering when you are dealing with satellites, with GPS, and with other, I don't know, ships, spaceships. So be aware. If you are working for the first time in something that connects with satellites or something like that, read a little bit about this, because these effects might be important on your software. Months and days vary in duration depending on the year. This is the leap years effect. And then one more: day, week, month have different meanings in different contexts. I worked for a medical software at one point, and we were discussing things like prescriptions, like you prescribe drugs for a week, for a month, for 3 months, something like that. And the question was, okay, how long is a month? And it turns out that months have different durations in different contexts. In that case, a drug prescription month is exactly 28 days. And there's a reason for that. I'm not sure this applies to every country. Okay, maybe it just applies to the countries this product was aimed at. But it makes sense if you think that a drug bottle will have a certain number of pills. So it's easy to have multiples of 28 in a drug bottle, like 28, 56, and so on. And then it's easier for doctors to prescribe like 1 bottle or 2 bottles and so on. So in this case, it makes a lot of sense why a drug prescription month will be 28 days. But as you can see, this is very different from the calendar month, which can be, of course, 28, 29, 30, 31 days. So don't assume when people are telling you, see you next month or see you in 3 months. What does this mean? Does this mean precisely 3 months, depending on where we are today? Does this mean on the same weekday in 12 weeks? What does exactly mean in your context? This is the DateTime arithmetic that can become quite complex depending on the context you are working in. So how to deal with these issues? Well, first of all, store UTC time, display in local time zone if needed. This is the most common thing that helps. I've often seen software developers who are first storing dates and times on the server in the date and time of the server. And the software would work perfectly as long as the server was in the same region as the clients. So for a while it might have worked, right? Because maybe you had the server in Romania, you had the clients in Romania, all fine. But then suddenly, you get customers from, I don't know, US or other countries in EU, and then you have a big problem because you have stored all date and times on the server in the local time zone of the server, and then it's very difficult to switch. So maybe it's a moot advice at this point, since many of you are dealing, I imagine, with cloud deployments where servers are anyway in another place. But even so, don't assume that the server will serve only one time zone. It might serve multiple time zones. So lots of challenges there. Maybe it's not such a big problem in terms of bugs. I mean, the bugs would be that you see the time slightly different on the client. The challenge is to fix them, because you need to adjust from the time zone of the server to the time zone of the client, and then you need to start computing do a lot of silly conversions between these two. And you need to ask the client for the time zone and so on. So it starts to become a little bit complicated. It simplifies your world immensely if you store UTC time. That solves also a bunch of other issues. So yeah, and then display in local time zone or convert to local time zone and so on. Second thing, test for the edge scenarios. Things like date change, hour change, 29th February, a leap second. And be very careful with the time and date arithmetic. I've already talked about this. What does it mean that you had, if you had 1 week, if you had 1 day, if you had a few hours, it's fine. If you had 1 week, it's fine. What does it mean to add 1 month, 2 months, 3 months? What does it mean to add a year to the current date? Be very careful with that, because it's not as easy as it seems, and it depends a lot on the factors that we already discussed. So then how do you do this with software design? Because how do you test, right? So one way you could test is to set the clock to the computer clock to various special dates, and see how the software deals with that. That's not an easy thing to do. It's quite complicated, because we want the clocks to be synchronized. So while you can play with it, it's quite fun, but it's not the best approach and the fastest approach, the most effective approach to find these issues. So instead, what you could do is to avoid calling the datetime.now method like it is in C# or the similar functions in Java in your programming language. And you have 2 different options depending on what is the thing that you are looking for in your code. One option is to inject a clock or calendar object that you can stub. So what this would mean is that you'd have something like an iClock, which is an interface, right? And it would implement a single method, current time, return the current time in some kind of specialized type. We'll talk about this in a minute. And then one implementation of this would call your system clock through your programming language construct, The other implementation can be stopped to return whatever value you want. So in this case, you could return 29 February and other things like that. Now, this is useful in case you are having a longer collaboration between two objects. So you have an object clock or an object calendar, and it collaborates with your class. Your class requests multiple times the current date, the current time, and then it does performs some algorithm based on that. And you want to test that this algorithm works correctly, no matter what the date time values are passed in. So this would be a valid approach. Personally, I favor the second one, which I find much simpler because it reduces coupling as well. Inject the date time values directly. So what this would mean is that you would have a class that calls your algorithm with the date time. Or maybe first you collect the date times that you need, and then you pass them to your function that is an algorithm. And that function you can then test very easily by creating the datetime objects and passing them. Now, depending on where you are and what problem you're trying to solve, both approaches are fine. The second one is creates less coupling because you don't have this need to introduce a new object that wraps the system clock. You don't need to stub it. You don't need to do an implementation of it. It's quite simple to just inject the values directly. But maybe sometimes you cannot do that, or you prefer the other way around. Fine, both work. The goal of these things is to allow you to test your algorithms using different values for date time, which include these weird values that only come every 4 years or every 400 years or so. And you specialize types like date time instead of primitive types. Of course, nothing stops you from having like an integer for date, an integer for month, an integer for year, and then play around with these things. Problem is if you're doing it like that, the arithmetic of date time becomes difficult. So an advantage of using this specialized type like date time, time span, or duration is that you already have this arithmetic implemented, tested. You have the daylight saving time built in. You have a lot of things that are the time zone built in. All these things are there, and you can convert to whatever you need much more easily. Now, the last time I used Java, there was a problem with datetime. It was very complex, and I think the recommendation was to use DateTime. I think in the meantime, in newer versions of Java, it's better. For other programming languages, you have to read, I don't know precisely for each of them. All right. So let's look at a bit of code and see if we can find the bug. This is C# code. It says datetime dt equals datetime.now, so it gives the current datetime. And then it does datetime result equals new datetime of dt.year plus 1, so increments the year, dt.month, dt.day. What is the problem here? Well, if you run this on 29th February 2024, it will try to create a date of 29 February 2025, and that will fail. Probably throw an exception. I haven't tried it. So this leads to a bunch of issues, and Microsoft has had a lot of problems with leap year bugs. Um, Microsoft Zoom stopped working on 1st of January because, if I remember correctly, it was after a leap year. Microsoft Azure was down on 29th February. I don't remember the year exactly. So even very large companies have issues with this. Be careful whenever you're doing that. Here's how I would like to see arithmetic, DateTime arithmetic done. This is an example from Groovy. Groovy has something called the time category, which is kind of an extension of the language that you can use for a specific code block. And in this case, you say use groovy.time.time category, because in the next code block, what we are doing is doing some DateTime arithmetic. And so it has something like print line 1.minute.from.now, print line 10.hours.ago, and these all work, which is amazing. And then my favorite thing, let's say you have def sum date equals new date. This will give you the current date. Print line sum date minus 3.months, and it will give you 3 months ago based on the correct arithmetic depending on the current date. This is what we should have in more programming languages, because this is amazing. It simplifies the code. I can understand it. And of course, if you can replace 3 with variables, it's very easy to read. All right, leap year algorithm. So another thing worth mentioning, 2000 was a leap year, 1900 was not a leap year, except in Excel, where if you're asking Excel, it will consider it a leap year incorrectly. But it's part now of the standard for spreadsheets. So 1900 most likely in your spreadsheet application is considered wrongly to be a leap year. 2100 will not be a leap year. So just checking division by 4 is not correct. What you really need to check is that if it's a centennial year, it has to be divisible by 400. So this is why 2000 is a leap year, 2100 will not be a leap year, because 2100 is not divisible by 400. Now, if you are lucky, the software that you are writing today will not live up to 2100. So maybe you don't care about this. It was something interesting to know for 2000, but now we still have some time to go to fix this, hopefully. All right. What test values can we use? Well, this is what I would recommend. So if you write your code, as we discussed, with the ability to inject the date time either as a value or as a stub, then you can write automated unit tests that check your algorithms for various things. And these are some important values to keep in mind. The beginning of the year, 1st of January, the end of the year, 31st of December. And if you want to be more precise, it would be 1st of January, 000000 or 000001. End of year, 31st of December. Again, you can go into more details. Beginning of day, 0000. End of the day, 23:59:59. In case you have a system that depends on leap seconds as well, end of day will leap second. Typically, the leap second is either in June or in December. In the past years, they've added it in December, so it will probably be 31st of December, 23:59:60. This would be a valid date time. Now I'm not sure if this is something that works in current date time implementation, but who knows. Leap year, for example, 29 February 2024, and this is the first I would try if I were you, because if you try it today, you still have some time to fix your leap year bugs before they happen. Different months, 30 days, 31 days, 29 days. Simulate daylight saving time. How do you simulate this? Well, make multiple calls to the function. First call with, let's say, 2:59:59, then the next call with 4. First call with 4, the next call with 3:00:01, and see what happens. Unless you're doing UTC, in that case, it doesn't matter. Simulate crossing the date line. So make a call with 23 March, make a call with 22 March, for example. You can use whatever value you want here. It's particularly funny when you combine these, so it's like combine beginning of year with crossing the date line. So now I'm on 31st December, then on 1st January, then on 31st December again. So you can do, and then if you combine this crossing the date line with a leap year, might be something interesting. Okay. Now, this will cover the common issues that we discussed about, but there are other situations that we haven't even touched upon. And there are two big situations that you need to pay attention to. Different calendars, like the Chinese calendar, relativistic time, speed and gravity effects on GPS and satellites. I would also like to mention one more. We did a video on this, but for a few days, one country, I don't remember which country, had 2 time zones at the same time, because there was one time zone recognized by the government, another time zone recognized by the religious authorities, and it was a bit of a mess. So that's very difficult to factor in. It's presumably not something that happens often, but be aware that time zones, date and time, they can be quite difficult. All right, this was it. Date and time problems and how to avoid them. Yet another explainer. Leave us comments if you have seen these problems happening. What problems have you seen in the code bases that you are working on? Problems relating to time zones, to leap years, to transitioning between time zones, traveling between or crossing the international date line, relativistic effects. Have you seen such bugs? Have you caught such bugs? Did you have to fix such bugs? Let us know in the comments, and I hope this helps you avoid headaches on the next 29th February, which is coming close. Thank you kindly for the view, and until next time, remember to think, design, and work smart.